In today's video, we're going to look at how to add and subtract polynomials. So eventually, the goal in this video is going to be to look at questions like this. So you may have seen this in math class before, but we're going to work our way up to it. So you might see questions like this where I have a string of terms or a polynomial and I'm adding it to another, or I can have the exact same question down below, but I'm subtracting it. So these are the questions that we are going to be able to do by the end of the video. Before we get there though, a lot of people find math confusing once you throw in those X's or Y's. So let me demystify that for you a bit, because really you kind of know how to do that intuitively. So let me give you an example. So let's say I have two kids, Rose and Noah, and let's say they both go to a grocery store. They each grab a grocery basket and they go grab some apples and grab some bananas. So Rose happened to grab 5 apples and 3 bananas. Noah happened to grab 2 apples and 1 banana. If I said, can you tell me how many fruits do they have altogether? Well, I think you can all say 7 apples and 4 bananas. But how would we write this mathematically? Rather than saying Rose has 5 apples and 3 bananas, I'm just going to use a letter. So instead of apples, I'm probably going to use A. So we call these let statements. These define what we're using. So let the letter A represent 1 apple. Let the letter B represent 1 banana. And just so you know, if I just have an A, that means 1 apple. If I have 2 A's, it means 2 apples. If I have 4 B's, it means 4 bananas, and so on and so forth. So let's take a look at Rose and Noah then. Rose has, we would write this as 5 apples, so 5A. And because she also has bananas, I'm going to do a plus. Now she has 3 bananas, so I'm going to write plus 3B. I could say Rose has 5A plus 3B if I wanted to have, an expression for what Rose has. So what would Noah have? If we take a look up here, we have 2A for 2 apples plus 1B. And one thing I should let you know is that whether or not I have the 1 there, 1B is the same thing as just B. So if you ever see me write it as just a B, know that there is an invisible 1 that I can always write in if I need to. We just leave our final answers without it. We like things to be as simple as they can. So I can also write an expression for Noah over here if I wanted to. But basically, this is us starting to introduce letters, kind of like this kind of question up there. But the letters usually stand for something, and in this case, A stands for apples, B stands for a number of bananas. So what if I said, how many apples and bananas do they have together, or what's the situation when I combine them? So all together, what do they have? So if I want to combine them, now I'm in a situation where I'm adding these two things. In other words, I'm going to take what Rose has in her basket, and I'm going to add it to what Noah has in his basket. So it's going to look like this. Here's what Rose has in her grocery basket, and then I'm going to add what Noah has in his grocery basket. Now that's not as simplified as it can go. We talked about how, looking at this picture, we have 7 apples and we have 4 bananas. So how do we get that from an equation like, an expression like that? An expression like this? Well, I'm going to take those brackets away. It's almost like I'm taking the fruit out of the basket. Maybe I'm putting it on a table. So I have 5 apples and 3 bananas. And then beside that, I have Noah's 2 apples and 1 banana. So what we can do is move the bananas together. So imagine on a table, I'm taking this 1 banana and I'm moving it over here. Maybe I'll start with the apples. Imagine on the table, I'm taking Noah's 2 apples and I'm moving it over. Here's what that looks like in my equation. I'm going to take these 2 apples, the 2A term, and I can actually move it over so that it joins the 5 apples there. And now when I'm dealing with the 3 bananas, I'm going to write my 3B, because I'm just going to start with what Rose has. And then it's as though I can take this banana and move it over. So how am I going to write that? That's me saying, let's take this 1 banana and I'm going to move it so it's beside the 3B. So in other words, I'm placing apples together on one side of my expression and bananas on the other. And now that these are written that way, I can say, well, these two will add to 7 apples, and these two will add to 4 bananas. So that's our final answer for this. And again, the whole point of today's lesson is we're trying to learn how to simplify polynomials. So we'll see that we had an expression here that wasn't so simple, but using some math rules, we were able to get it to this much more simplified form. And again, letters, if you go back to this analogy with apples and bananas, X's and Y's are not that different. And I'm going to show you another analogy when we want to use X's and Y's so that if you like to have something concrete to come back to, you can. So let me give you a different expression. So I've left these apples and bananas behind. I'm not talking about Rose or Noah anymore. I'm giving you this question. So let's say you're sitting in math class and you see this question. Well, what does it mean and what can I do with it? Now, in a previous video, I showed you this side of a poster set that I have. And if you had watched it, what we talked about was we said, well, if I have a question like x plus x, how you could visualize it is you could say, let's imagine that each of these x's is like a wooden tile with the letter x on it. So x plus x means I have this x and I have a second x. So this x and this x. So if I'm adding x plus x, let's count them. We have 2 x's, and that's where this came from. Now this letter x is still there because it has to tell me what's written on that tile. So for example, if I had had a y plus a y, I have one tile that says y, another tile that says y, and now I have 2 tiles that say y. So that video is available on my channel if you want to see it. Let's use that same analogy to kind of explain this one here. So my 4 x's, what would that look like with our tiles? So I've got my tiles here. I'm going to grab these 4 x's and my 1 y. Now, I wasn't able to redo it with the y on it. So there's my 1 y. Let's make it a bit bigger. That's what this first bracket or basket has. Now my 1x over here is represented by 1x tile, and then my 3y tiles can be represented or shown this way. So this is kind of a visual representation of what this question means. And my goal with this is so that you don't just look at this question and go, oh my goodness, what are the x's and y's? I don't get it. It's so confusing. Well, if we break it down, what does it mean? It means I literally have 4 x's and 1 x in one basket. So imagine this is one grocery basket. And then I want to combine it with 1x. And again, remember, when I just have an x, there is always that invisible 1 in front of it. I drew it in here, but it won't always be drawn in. And usually it actually is going to be missing. So we can add that in to help us understand. So we have the 1x here, and we have 3 y's there. So what we have to do first is, again, pretend these are in baskets. We have to take them out of their baskets first. We have to get rid of these brackets. Now, one of the rules that I'm going to be showing you eventually down here is that I want you to notice when I have a positive sign in front of a set of brackets, or even an implied invisible positive sign, what you should notice that we've been doing is these brackets can disappear. And so we've copied out just what's inside here. Okay, so I'm going to do that here. So once again, I have these invisible positives in front of that bracket. If it wasn't positive, it would actually have a negative sign, which our question doesn't have. So I can get rid of this bracket. Got a plus, I can get rid of this bracket. So let me rewrite what I have. I now have 4x plus 1y, and I'm combining it with 1x plus 3y. So just like what we did over here, moving our B's and A terms around, we're going to do the same thing with this question as well. So I'm going to take this x term here, that's my 1x, and I'm going to make it go side by side with the 4x's here. So the way we write that is we take this and we move it over so it's beside the other x. Then combining that with, I have a 1y, so I'll write my 1y. Let me try to color code it. So my 1y comes from here. And I want to bring these 3y's over to join it. So my plus 3y comes from this. So now this is what we call grouping like terms. grouping, or sometimes people call it collecting like terms. Okay, now a like term is just a term that has the same number and exponent. And I'm going to talk about that in just a second. So now if I take a look at this, I have 5 x's and I also have a total of 4 y's. So this is 4 plus 1 gives me the 5. 1 plus 3 gives me the 4, but I still need that letter there to tell me what was written on that tile. So before I go on, I do want to just briefly talk about what terms are. So we've been talking about, well, ultimately we're going to talk about things like terms. So what is a term? Well, a term is a basic unit in an expression. So for example, I could have 4x, I could have, let's say, 5x squared. These are each terms, and a term is made up of this number in front. We call that a coefficient. That's just a number in front. So the coefficient here would be, would be 4. The coefficient here, there's my short form, would be 5. And then this letter is my variable. Okay, now sometimes our variables can also have exponents attached to them, but this entire unit is what we would call a term. Same thing with this. This whole unit is what we would call a term. So how do we know if something is a like term or not? Well, a like term would have to have the same variable or variable exponent combination. I want you to attempt this question. Now, this is a question that's a little bit harder than the ones we went through together, but I want you to apply the concepts that we learned. Don't memorize don't memorize what I did, but think through the concepts about what this means and then give it a shot. You will likely get to a point where you're not 100% sure if what you're trying is correct, and that's okay. I do want you to be brave enough to attempt something and to guess even if you're not sure, and then to get some feedback about whether or not you were right. And that's how you learn. So do not be afraid of being wrong. If you were sitting there and it's a test and you had to guess, what would you do? And then let's see how it goes. Now I will start you off though with reminding you that there is an invisible 1 there. So if we're talking about tiles, this situation would look like I've got 1 tile that says an x squared. Here I have 3 tiles that say x squared. Okay, and so that's kind of how we would bring the tiles in when there's an x squared. Okay, so pause the video and come back when you think you're ready. Okay, so I had mentioned over here that we do need to take out our brackets. We have to get these out of the baskets, if you will. So I had mentioned that if there's a positive sign, we can get rid of these brackets. Here's a positive sign, I can get rid of those brackets as well. So that's going to be my first line. I'm going to copy out the insides of those brackets, and I'm not going to worry about the brackets themselves. I'm getting rid of them. At this point, now I can group my like terms. So one of the ways I like to organize my working is I like to underline the different types of like terms together. Sometimes I call them families. So I have the x squared family. There's an invisible 1 here. I have the x family, and if you have just a pencil and no colors, you can always use different kind of lines to highlight that. And then I have what we call the constants. The constants are just terms that have no variable. So I'm going to rewrite them. I'm going to bring my x squareds together. So I'm going to bring this one over. Now just remember that when you're moving a term, this sign just in front of it belongs to it. So I'm not going to write it as negative 3x squared. I'm going to write it as positive 3x squared because that's the sign that belongs to that 3. Use maybe the right colors. Now I'm going to deal with the x's. So I've got a positive 3x from here. And then this is a subtract 5x. And then for the orange bits, I'm going to copy out a negative 2 because again, that sign comes along with it. And then a positive 1. At this point, now I'm going to add, I've got 1 tile that says x squared. And then I have 3 more tiles that say x squared. So now I have 4 of those tiles that say x squared. For the pink ones, this is a little bit harder to visualize with tiles. We've got 3 tiles that say x. I'm taking away 5. Well, that's a bit trickier. So the trick is just take the integers. So 3 minus 5 is negative 2. And just know that your tile still says an x, so I need an x there. And for my constants, -2 plus 1 equals -1. Now, if you were thinking that -2 plus 1 is -3, you've made a common mistake, and I would just encourage you to watch my integer video. I'll try to remember to put it in the link below, and that'll give you a really quick and easy way to sort out those negative signs and not make mistakes because of them kind of once and for all. All right, so hopefully you got that right. Now, if you didn't, and that's okay, I want you to take note of where you went wrong. So ask yourself, where did I go wrong? So for example, maybe I made a mistake here. Do I know why I went wrong? If you do, great, move on. If you don't, ask someone, watch a video. But you basically want to make use of all of your mistakes. We generally don't understand a concept perfectly the very first time, so it's important that we try, take our best guess, and then get immediate feedback about whether or not what we're understanding is correct. So that's what trying things out and making mistakes is all about. Okay, that was just a little study skills blurb. Now we're going to look at subtracting polynomials. All right, so I've copied out the same situation of our Rose and Noah situation, and I've copied that out down here. But now we're subtracting. So instead of these two people combining, what they have, I want you to imagine that only Rose goes to the grocery store. This is her basket. She gets 5 apples and 3 bananas. She goes home, and Noah gets to request some. So she's bought some of this stuff to share with Noah. So let's say Noah says, I'd like to take 2 apples and 1 banana. Now, first of all, I'm hoping you can see that this is not an addition situation. We're not combining them. We're taking these items away from this total. So when we want to subtract polynomials, what we could say is, in this situation, I could say, here are the 5 apples and 3 bananas that Rose had, and I'm going to subtract what Noah is requesting, what Noah wants to take away. So how do I deal with this when I have subtraction? So with addition, it's fairly simple. With subtraction, I do need to go over some stuff with you. Often teachers write it vertically initially, just to kind of explain the concept. But ultimately, you don't want to have to do it vertically. We're going to move to going horizontally. Now, vertically is great because you've learned how to do things like this when you were younger, so we're going to use the same kind of concepts. So I'm going to say, well, let's just focus on the apples first. So if I take 2 of the apples that Noah wants, take that away from the 5, what I'm really doing is I'm saying 5 apples minus 2 apples. So that part's going to give me the 3 apples, which we're used to. How about for the bananas? So for the bananas, I have positive 3 bananas, and now I'm not going to add 1 banana, right? If I just focus on this and I ignore this sign, it would tell me that, well, what I'm left with, what Rose is left with, is 4 bananas, which makes no sense. So the thing I really need to drive home is when you're subtracting a set of brackets, you are not only subtracting the 2A, the 2 apples, you're also applying or subtracting the bananas as well. So that subtract applies to everything in the bracket. That's an important thing. So this subtract applies to everything in that bracket. So we would write that this way. We would get positive 2B, and so this would be our answer, which is what we would expect from our picture. So Noah takes 2 apples, he takes 1 banana. So Rose is left with 3 apples and 2 bananas. So again, that's the way to write it vertically. We don't want you to have to do that forever. So let's look at how we do it horizontally. We're going to use our math laws to get rid of the brackets. We have to get rid of these brackets here and here using correct math rules, which I'll talk about in a second, before we can start to rearrange things. And when I say rearrange, I mean things like this, where we were moving them around and grouping our like terms. So for this first one, we should hopefully be able to do. We learned that with a positive, we can just get rid of these brackets. So let me just get rid of this bracket there. Now, what do I do with the negatives? Again, what we're really doing is we're saying we need to subtract off a positive 2A, but we also have to subtract off a positive 1B. So at some point, you'll be able to do this in your head, but for now, we're going to write it this way. We're going to subtract this positive 2A, and then we're going to subtract this, let me color code it, and then we're going to subtract this positive 1B as well. Now, why did I write it that way? It's because we already learned in a previous video what to do about double signs, as in these signs here. And we learned that if they are different, these combine into a single negative. These combine into a single negative. So I'm just going to rewrite this with the single negative sign rather than all this stuff that I don't need anymore. This is now a question very similar to these, where we can just rearrange them and group our like terms. So I'm going to take my 5a, I'm going to move this negative 2a over, and remember it came along with that negative sign there. And then I've got my plus 3b, and I'm going to move my negative 1b beside it as well. Grouping my like terms, I have 3a there. This gives me positive 2b, and these are unlike terms because one is an A, one has a B, so we can't go any further and we can't add them. Please double check that when you are doing this question, you have a plus symbol there. It's really important that that's there. Otherwise, it could look like a different operation like multiplication, for example. So going back to this note, it's really important. You have to get rid of or deal with your brackets before grouping your like terms using your correct rules. So what are these rules that we've talked about? So key points. If a bracket has a positive sign in front, you're allowed to just drop the brackets, and that's what we did here. But if you have a negative sign in front, that negative sign applies to each term within the bracket. And so that's why we wrote it out as subtract this and subtract your 1b. Now, as a check, and some teachers teach this as the method to deal with the brackets, which is also right. This might just explain to some of you who want to know the why a bit more, why this is true. But you'll find that the original signs of each term get flipped if you do it correctly. So what do I mean by that? This original sign, so because this is a subtract, let's see how our signs get flipped. This original positive sign turned into a negative. This original positive sign for the 1b turned into a single negative. So that's what we mean by that check in terms of flipping the signs. So I'd like you to stop the video and try these two questions. These are two questions where one's a plus and one's a minus, so just be careful. I want you to use these rules and then come back and I'll take it up really quickly just so you can double check that you're on the right track. With this first bracket, we're allowed to just drop them. With the second bracket, because it's a plus symbol there, again, we can just drop those brackets. When I group the like terms, my x squareds go together here. And I am going a bit faster because I'm assuming that you've had a chance to try these questions on your own. So this is the answer that you got. If you did not get that answer, pause the video and compare line by line to see which one of your lines is different than mine. See if you can understand where you went wrong. Now, some common mistakes would be the negative sign here often throws people off. Remember, we'll just deal with the integers first. That's where the negative 4 comes from. And then the variable still stays the same. That's the tile that we were working with. This, if you got negative 8, again, you're just making a common mistake with integers. And I have a video for that. I think it's the very first integer video that should help you with that. The second one, right, so because I have a positive in front of this bracket, I can just get rid of it. Because I have a negative sign here, I can write it out this way, where the negative sign applies here. Let me see if I can, the negative applies to that. The negative also applies here, so subtract a negative 6xy. And then I also want to subtract a positive 1. Whoops. And I can turn that into 1 negative, a positive, and a negative. Now, soon you should get comfortable enough with this method or with these questions that you can jump straight to the line I'm writing right now. Okay, so hopefully you can go from here to here eventually, which is why some teachers teach you that you can just go from the positive to a negative, negative to a positive, positive to a negative. It's kind of a shortcut. Or I just like to say in my head, subtract a positive. I know those are two different signs, so that's negative, just because this is multiplication. Subtract a negative gives me a positive. Subtract a positive gives me a negative. I'm using that rule of different signs give you a negative, the same signs give you a positive. So I'm going to quickly write out my like terms. These give me 1x squared. And remember, you don't need to write the 1 there. You can initially, but I'd like you to take it out because it's more simple without it. Over here, I'm going to do my integers. So -5 plus 6 gives me +1. So once again, rather than writing +1y, I'm going to drop that +1. Sorry, I think I meant to say +1xy. This has no other like term like it, so it's on its own. Same thing with our subtract 1. So this is our final answer here. These are each unlike terms, and so we can't go any further. So that's our answer. All right, you try. So these are now 6 questions that I'm hoping you can do if you've watched the video. Now I have thrown in a few slightly different ones, like for example, this is slightly different than what we've covered. However, if you've understood everything we've done up until now, you should be able to take some really educated guesses and feel fairly confident that you're doing it right. How I want you to do these questions is I'd like you to try question A first. Don't move on to B, C, D, E, and F yet. I want you to unpause the video, and then for the next bit, I'm going to kind of take up the answers for each one. So again, you'll do question A, unpause the video, take a look at your answer to see if you got it right or wrong. If you got it right, move on to B and keep doing that. Now, it's really important that, let's say you got a mistake on part B, make sure you figure out where you went wrong, what you misunderstood, and what the right way of doing it is before you move on. What you don't want to do is do all the questions, have, let's say, one common mistake that you make in all of them, and now not only did you not get the immediate feedback, you've now become a real expert at making that one mistake. So it's going to be even harder to unlearn that. Okay, so pause the video, try A, come back. Pause the video, try B, come back. All right, so if you've finished A, this should be your answer. So I'm hoping that what you've done is, because we've got positives here, you can just get rid of these brackets. Same thing with this, you can get rid of these brackets, and that's how you would get this answer. If any part of the answer is wrong, just take note of it and ask a teacher or a friend when you get the chance. Pause the video, try B, and then come on back. All right, answer for B is this. So again, I've got a positive here. I can get rid of those brackets. This subtract has to apply to both of these. So your next line down here would have been -6x and then a +1 by the time you got rid of those brackets. All right, pause, try C. And again, if you are making any mistakes in A or B, take a 30 seconds, a minute, really sit with what that mistake was. Why did you get it wrong? What are you misunderstanding? Why does this correct method make more sense? So really learn from those mistakes before you attempt the next question. So pause it, go ahead and try C. And here's our answer for C. So again, these brackets end up disappearing. This, by the time you get rid of the brackets, you have this. Pause that, try D. Now D could be a little bit harder in that I have a negative sign here as well, but all that means is I need to apply that subtract to the first bracket as well as this subtract to the second bracket. So unlike A, B, and C where I could just take out these brackets, I actually have to do that twice here. So what I would have had for my first step here would be -4x plus 3 minus 7 plus x. And you would have maybe had to do that in a few steps. All right, try E. And come on back. Here's our answer for E. Okay, so again, this, you'd be able to just get rid of this. And over on this side, these are the signs you would have had. And finally for F, this is your answer. So again, with this one, don't need this. And because that's a plus, I actually don't need these either. So this step, the next step here, would have looked like this, where I just copy all of this out, signs and all. And then from there, I would group my like terms and simplify. If you found this video helpful, please like and subscribe.